Okay, so yeah, in the last yesterday's session, you learned about a pod. Pod is the smallest unit in Kubernetes, which runs multiple containers, and pods have an IP address. And last session, you saw exactly how Flannel was able to assign an IP address to this pod, right? And that IP address is what is used for routing two pods. So currently, if you have two pods, I think. Not sure if you had this client and server pod yesterday. If you have two pods, you can communicate between these pods, a server pod and a client pod. The client pod is able to talk to the server pod using the CNI. They get an IP address and the routing is also handled by the CNI. So everything that is pod-to-pod networking is currently handled by the CNIs. So what is still missing? Why do we need a higher level abstraction, right? The problem is pods can come up and go down anytime, and this means that if your client code has to talk to a pod, it should have hard-coded the server IP. And this means that since IP is unstable, this means your code has to keep changing now and then, or at least your configuration has to keep changing now and then. And the second thing is that there could be multiple replicas, right? If there are multiple pods serving the same service, which one do you have to talk to? Why should you hard code to only one of them when you could be load balanced between multiple of them? So to handle both of these, we have this new network abstraction called a service that Kubernetes provides out of the box. Just a sec. Yeah, let's just see how services work. So so just summarizing what I just said, a client could talk to a server directly. That's how if you just refer to the pod IP, you can talk directly. And if you have a service, you can connect to the service instead, which will have a stable IP, and it will be able to do the handling of talking to the pod internally. So this diagram will come up multiple times. Let's just see all the pieces in this diagram, right? So the gray boxes are nodes. Nodes have an internal IP shown in pink. That's just the network in which they talk to each other, and shown in purple, sorry. And in pink, you have the external facing IP of the nodes. The node could be a bare metal, it could be a VM, and it has a server. Have a pod IP, and it could be on another network, right? And this IP is set up by the CNI. And like I said, pod can talk to pods using the CNI. Now services, there are three types of services. They kind of build upon each other. So the first is cluster IP, second is node port, third is load balancer. We will see each of them in detail. Yeah. So let's assume you have multiple server pods and you have a client pod that wants to talk to the server pod. So what you do is stand up a service, and this service is only for these pods, right? And the service comes with a cluster IP for that service. Now instead of referring to the pod IP, you will now refer to cluster IP : port. For instance, just refer to this service, cluster IP here. Or if you're using DNS, for instance, Kubernetes has this kube DNS that it comes with. If you're using DNS, you could actually just very conveniently just use the service name : which makes it a bit more understandable in terms of application, higher level application functionality, right? So now the client will talk to the service, and the service will handle talking to the pods. So you have a single stable IP that you can always communicate with, and it will talk to the underlying pods. The problem with this is, this service IP is only accessible from within the cluster. So if you have a client who's outside and he wants to talk to this service IP doesn't make sense to anybody outside. They have to be within the cluster, which means another pod or something else which is running on this cluster. Now you saw that there are multiple pods that are backing this service. So how do you split traffic between these pods, right? So kube proxy, which is a component in Kubernetes, handles this load balancing, and what it does is random splitting to get almost equal load balancing. So it just says send it to this guy or send it to this guy randomly, and you'll get equal load balancing between the multiple backend pods. So like I said, there's a issue here that is only accessible from within the cluster. So how can we fix this? So that is why we have a second kind of service, which is called the node port service. So same diagram as before, you have multiple pods, a client wants to talk to this server. You create a service as before, the same as before. Now additionally what we do is that we do port forwarding of this service to the node itself. So the node's port 30,000 here refers to a service 8080. This is called the node, this is referred to as the node port. Nodes port, right? And this is on every single node that exists in this cluster. So now the client, if it has to talk to the pod, will refer to the service, but instead of referring to the service name, it will refer to the node's IP :port. And like we said, node's IP here, this one is accessible from outside as well. So this means that a client inside can refer to this node's IP :30,000 to refer to this service, which will send it to the pod, which will take care of sending to the pod. And you can also actually send it from outside. You can also send it from outside, and that is not a pod within this cluster, and still be able to refer to this service. So this ensures that it is accessible from anywhere in the node network though, which means you still have to be able to access this 4.4.4.2. For instance, if it's a machine in the IIITD server, you can access from the guest network, yes, but you can't access from maybe mobile data or something, right? So the third thing is load balancer, which is so that it's accessible from the internet. And again, like I said, it sort of builds on each other.
So, quick interruption.
Yeah, sorry, quick interruption. Service, so you have seen service, this green box, a few slides, right? So raise show of hands. What is the service? Do you think it's a container? Okay, what am I hearing? Yeah. Protocol type, okay. Any other cases? What is it? Is it a container? Is it a pod? What is it? It's a sidecar. Sidecar is a guess here. Any other options? Okay, so I mean all of them are close but not right exactly. So like I said earlier, service is an abstraction, right? So it's essentially it's actually nothing. It is just a virtual thing, right? It's not actually anything. Kubernetes is giving you this new concept, and it's asking you to create, like you created pods and deployments. So when you created a pod, you took a YAML, you upgraded it, and then you got a pod, right? So at least pod is a real container, right? Inside a pod is a real container, so that's something that's running, right? But if you take something like a deployment, you create a deployment. But what is a deployment? It's 3 pods, right? But apart from the 3 pods, there is also this deployment resource in the cluster, right? So similarly, the service is a virtual resource that Kubernetes is providing you, and there is a full system behind it that is implementing everything that Kavya has been talking about, right? How is it routing between the service to the pods? How are you reaching from the pod to the service, right? All of these things, there is a lot more infrastructure that actually does the work, but it is just not structured. Hope that's clear.
Okay, yeah, the third thing is load balancer. It sort of builds on top of both the cluster IP, that's the first kind of service, and node port, the second kind of service. Where you have an external load balancer. So an external client can talk to this load balancer, which will talk to the node port, which will talk to the cluster IP, which will talk to the pod. So you can see there's like multiple layers of redirection happening in this. Virtual redirection, we'll see how a service works. First so the hands-on part will involve you implementing a service and deploying it. We have slides on how a service works. We'll see if we can get to it or not later. Okay, so I have shared a services.tar.gz on Slack. Can you guys get it on your machine, on your VM as before, and use the tar xvf command to untar it? And I So you able to untar it yet? Show of hands, are you able to see 4 files sitting inside the untarred file? Okay, so it has a config.yaml, which is what you'd use to access Kubernetes again. I hope you have the kubectl command. You might have to share. Okay, yesterday we shared this alias command of kubectl. You might have to rerun it if you have closed the terminal from yesterday. So please just rerun the alias kubectl command from yesterday's Slack. Can you share that context wala thing also? The current context setting thing. In your slides, there was this thing on set the current context, right?
Just.
Yeah, so verify your kubectl command is working correctly. You have to be in the same state you were in yesterday. You should be able to access your own namespace, right? So you have to run that set config command again. So there is an instruction in Slack again
If you missed it, so please, just get to the same state where you can look at pods and you might be able to see the pods from your yesterday's deployment, right?
To tar. Yesterday it happened, no? Not tar it
happened. Is someone able to open it, or is it bad?
Is anyone able to extract the tar file?
Services
Okay.
naam saari.
Everyone is working.
Okay, then do you copy from outside or we?
Exercises naam kya hai? वो services से नहीं आया.
Services से
How did you move it in?
under है ना exercise.
No, I don't think wget will work for this thing. Slack will not.
Okay.
No, wait. It is possible Slack doesn't share that way. This is why yesterday I created a Python server
For
download it on your local machine, run a Python server on local machine, and then wget from local machine to this machine. This thing, I think a couple of people had this.
Do you remember what you did yesterday?
He didn't do it. I did it.
Huh?
You have to do it.
I think you have to. Did you download the file in your local machine?
Okay, if most of you are able to get it, this is the agenda for our hands-on, right? So there's a server deployment.yaml. It will contain some question marks which you're going to fill, so that its job is to print its own IP address so that you know which pod has been reached. So server deployment is talking about the server pod. We will bring up 2 of them and we have to change the command so that it will print its own IP. The second is the client pod. which also has some question marks. No, it will not have a question mark. I think it will have some square bracket, it will have some brackets in which you need, which already has some code, and the code is to continuously ping the server pod. And for that, you have to fill in the server pod, which you'll only get after you deploy the server. And finally, if you deploy this client and you see its logs, you will see that one of the servers is being pinged. Next, we will see service in action by actually creating a service for these pods. I will share the YAML with you. Right now, there's a service.yaml, but it's empty. And you will again change the client pod to ping the service IP instead of the pod IP. And you will see the logs again to see that this time it reaches different endpoints every time it curls, because it's able to, because of the load balancing that the kubeproxy does. So let's get to the server. Just open the server deployment.yaml. You can use nano, vim, gedit, whatever you like. Just if you have untar the file, just look at the server deployment.yaml. You can see there's 2 replicas, and there is some additional stuff over here where I have said this is just some custom stuff that you have done so that we can make the server pod do whatever we want. And what we want to do is print the host name of the pod that is serving. That is, whoever is running, the container that is running should print its IP, right? Print this host name. Okay, so yeah, your first task is to complete the server deployment. That is, fill in the question marks in the server deployment.yaml. I have a couple of hints here, or I will reveal the command, or you can go to the GitHub repo that we shared yesterday and the answer is there as well. But yeah, you can try it if you want.
Even those circuit control are not in conflict selling area.
Oh,
In the state like
oh, okay. Okay, what happened? Why did you install it? Just it was working. Okay, host name dash I. Oh, why? What? I did something yesterday. I got the. If config it. IP config. Something I did yesterday. Wireless LAN adapter. This guy is your IP. Okay. And now you download. It's sitting here, right? Python. You didn't need it. He had some, whatever he had yesterday was a http.server 8000. This is inside, right? Now wget control v colon 8000 slash service. This is tar.gz. Okay, tar xvf services tar.gz.1 cd exercises. Okay, now yeah, go to your Slack and get the alias kube control alias command.
So basically, essentially all the pods.
Just copy paste both of this command. It's in the same this folder only. And yesterday you created a user namespace, right? Host name dash I. You will get the IP address, which is also decent, yeah.
Now try that set context thing that you were trying, right? With the namespace from Slack.
So this is the summary slide, right? So if you get confused, if you get lost, come back to this slide and see where you are, right? And then try to keep doing one step at a time.
Then
So see,
but yours also you have to copy inside, is it? Oh, okay. Okay.
Also pod.
He's also copying. His work. Down. Where have you downloaded?
But the trick
Down.
is you have to find there is a template and you have to fill in the missing.
Okay, yeah.
But
Okay,
just start
I will
with the
uh,
simple stuff, right? Essentially,
if config.
start with this step 2 and then
Keep changing, putting around. This is your IP.
Okay, very good. Now you are in the equivalence folder.
Okay, now Python dash and http server. Okay, can you get a tab inside?
people are lost. They're not even sure first step in it.
That's why I said that is the name.
You have to keep reiterating. You have to keep saying where you are. But maybe that's not. Especially the fast ones are not attend பண்ணு. Slow ones only attend பண்ணு.
Okay, yeah, you should be hopefully in step 1 right now, where you're trying to complete the server deployment. I hope you, if you do finish it, I hope you remember the command you used yesterday to deploy a YAML, cube control apply -f of the file name. You can test it out. If something is wrong, then you have to change and write it again. Write the command. I think there's one more question mark also, which is the port. So you also need to add the port in order to get the whole thing to work. You can print something which identifies the pod. You do hostname I, you will get the IP. If you just do $hostname, it will print the name inside the thing, right? Which will be the pod deployment name. So either way, it is unique to the pod, so you can use that for. Did you do the deployment? No. It's okay. You used the host name, I assume. Okay. So anyway, that identifies that this is the pod that is receiving it. And you use the pod IP in the client. Okay, good. Nice. Yeah, you can see this thing and go ahead with the service as well if you want. Yeah.
Because I think you guys are using my machine as a gateway.
So you're doing that machine itself. You can. I think Shambhavi has she has a config which will work for people who are already on that machine.
Okay.
She has the normal config, not the modified config for your machine.
Not on that machine. My office machine where the gateway is.
Yeah. I think that config will work for anybody who can connect to the main machine itself, which includes your machine. So if you use her config instead, it will not work, yes. Okay, I wrote all over it. Okay, in case you guys are still not sure how to run this server deployment, you can put this command in the question mark, or you cannot look up if you don't want spoilers, and use the Nginx port 80 to finish the server deployment. Are you able to do the server? Did you change the client as well? You applied, okay. You can do kube control get pods to see if your server is up. Yeah, you have server deployment running in this thing. Okay. Yeah, you can use the slides and go ahead. So the next thing is you can go down. Client.yaml. Yeah. You just go to the slides. I think there's some more details in the slides. Next, yeah, you need to get the IP of the pod.
One second. No, that's your I have only.
No, don't do sudo. You control apply. What did it say? Do you have the config in the same folder?
Do one thing.
Config.yml is sitting here, and you run those two commands that were on Slack to get.
So there should be like the location of the exact config.my. So there is
Dot slash. Yeah, which is why I put everything in the same folder.
But even if you do dot slash, and if you run that any command, you cut command from other.
Yes, but all of this is lying in one folder only. The config and the server deployment are both in the same folder right now.
So she was having problem. I think.
Oh, okay. The problems because of that. Yeah, you can deploy the client pod also. You can fill in the client pod with the IP and where are people, man? Where are people? Everyone is going different pace.
Some people did not have the capacity to work, so now it's working.
Okay, can you all complete your server deployment with this thing? Can I get a show of hands if you have been able to fill in something in your server deployment and deploy it? The others you can use whatever is written over here in the first question mark in the server deployment, and then put port 80 in the server deployment, and then deploy it using the kube control apply -f server deployment.yaml. And then you can do kube control get pods to see the. Oh, I can just share that here. Okay, yeah, you can apply it using this first command. You can see the pods. You should see 2 pods being deployed if you run this, and you can get the pod IP if you use the command -override.
Yeah.
Are you guys able to see your pod IPs? Can I see a show of hands for this as well? Pod IPs, right? For those who are following along. Okay, you can get to the client if you have done the server deployment.
Service बनाओगे, service itself will select.
So -override give you 2 IPs, right? Just pick one of this is the simple one. Just pick one of the IPs, and in the client pod, you need to insert that IP there. Were you guys able to deploy the server?
She's facing. I'm facing the server.
Deployment in version 1 cannot be handled as deployment JSON cannot manage string. No. I think she's okay. Yeah, that one, that error is correct. Yeah, that is the alias. Are you in the same folder, exercises folder, right? There should be.
They have closed this once.
No resource found is also fine. That means that all your pods are destroyed. So you can, that is also correct only. Now just do the apply -if. Error when creating deployment version can handle deployment JSON containers port of type in 32. Port, just open the port part. They open your server deployment. No. Port should be 80. This should be the command. You did the client deployment also? Ah, okay. You can go ahead with the service if you want. You can go ahead with the slides. You can go to the service part. Are you able to run the kube control commands? Yeah, no, you have to go to the server deployment.yaml and make the changes in the question mark there. You have to put this in the server deployment.yaml. This question mark, you can replace this whole command with this erase echo also. You have to put the whole thing there. And niche in the container port, put 80. This whole thing. Yeah.
Validation.
Error validating data API version not set. Did you delete some lines from the old one, or are you running some new version of kube control? That's even. Error by API version not. Okay, there is some zero got added there. Could you just? Just remove that one.
Now the pod was.
Now you did dash o wide. Did you do? Did you get an IP of the pod? Now you need to insert that pod IP there.
But I've got two.
Just pick one of them. Anyone. You just paste the command over there and put the port. Vim is causing issues.
Yes.
So let's just see what we're doing, right? When you deploy the server deployment, you get multiple pods. You can pick any one of the IP and manually put that IP in the client. And when you deploy the client like that, you will see that it is always pinging that particular pod. And then there is a story that if this pod goes down, then your client will also not be able to ping it. So for this, you need to deploy a service. This whole thing is leading up to, if we deploy a service, how will things look after that, right?
When I run this command, it will show logs client pod.
Okay, well, it just show, go to your client port, right? I think :80 slash. This is :80 slash, correct? Okay, now what did you run in your server deployment? Oh,
So if you
okay, yeah, you have done to user share Nginx. Okay, just can you go to the slides? Go up a bit. User share Nginx HTML index.html. Correct. Okay, just go to your server deployment again. Okay, you have to put 80, but it's instead of saying hello, it is saying a lot of things.
just showing all those HTML files.
It is reaching Nginx, but it is it's doing something else.
So what IP address we are getting from these server, we have to put one of them.
One of them in the client. If you do -o wide, you will get IP addresses also. You put one of them in the client. You're able to reach it, so at least you got the connectivity. But I think you're not able to get your bin sh-c echo from dollar hostname user share nginx html index.html and client was colon 80 slash it seems to be right. I'm not sure. No, you were asking something?
What if we did not actually have client pod to know that it was port 80? Or Nginx was configured differently? How would we read the logs or figure out this? In Docker, we have like Docker inspect container. So is there something for this?
So you're saying how do we know at what port the
Yeah.
server pod is
If we
deploying?
didn't have all these things set up,
So yeah, at some point you do have to know what the pod, this thing is. Yeah, like you're saying, Docker inspector is showing because the pod has certain the pod YAML. This is the port you need to expose. At that point, you need to know that the container is exposing at this point. It requires user knowledge for that level. Because you are the one writing the container. You are the one writing the pod. Basically, it's like, at the pod you should know which all you want people to see, right? So metrics are usually on 3000. You may, if you don't want metrics to be shown, you don't expose it, or else you'll say expose 3000 also, and then say that metrics will be. So if you have a server, you know what port it is on. So those sort of things, you would usually say that I have 2-3 ports that I want to expose. So usually it's on the user to write that part. You did this. So go to your service.yaml. For instance, over here you put, right, 9000 is the port. So service has a separate port. You have to use that port instead of the pod port. Is it working for you? Yes. If you're done with the client, you can now create the service.yaml. You can try filling in these paths on your own. You can try filling in the service from this spec, or you could look at the code at this and the GitHub repo we shared yesterday, where the service.yaml should be lying. Maybe doing it and speed. So everyone's just following the slides on their own. No point of me being here. One sec. So this will, it said sleep 10 seconds and do. So it keeps going until you cut it. So basically you can see that because we use a service IP, it gives a different pod every time. And it's not exactly randomly between them. It just alternates between them every time. So earlier you just picked one pod, only that pod was responding. Now you put the service IP, you can get any of these.
Has everybody checked the names on the sheet? Because after this, we are sending it to reflecting, things won't change. Because I see that there are 2-3 people who have not mentioned.
You did think, okay, can you show your server deployment?
Nano type.
The nano, this one.
Aditya Induraj, is he available here?
But when I like apply,
Okay, no.
says
So,
This is the one you fill. So just fill fill the host name I so that, and you have to write it to the, you can just see the slides. I have the command in the slides. Basically, we wanted to go up a bit. Here, down here, this one, down here. We want to write the host name to Nginx HTML, index.html. So it will use that and it will serve that. So you'll know who is actually talking to you. So just call. It'll the dollar hostname means it will run hostname command and it will fill. So basically just copy this line and put it in that question mark area. Okay. So service, basically you can create a service, but it has to know what are the pods it is that you want to serve with that, right? So all of that happens with just this part, selector key value. So Kubernetes, in the pod YAML, you can have these labels that you can add. Basically, this is just some information you can put, right? You can say this is a production server, you can say I deployed it, anything you want you can put there. So service uses those label key value pairs to determine which pods to select.
So in the key, I have to put in what label I'm
Whatever, so when you create the pod, you put a label there. And when you create a service, you say selector of that label, and only and those pods will be matched.
Okay, so let's say that if I were to say that if pods created by you were to be affected with the service, then I would say then the maintainer's name and then colon and then name and then
anything you put in the pod, you repeat that over here, and it will select. It will just find those as the. So 2 ports. One is the first port is what port the service should be exposing. What is a port on the service that you want to reach, and the target port is what is a port on the pod itself.
So like external guy, someone who wants to connect to the service will connect to this
port, correct, and the service will connect to the pod target port.
Thanks.
Okay. Again, you just say that. So in case you just want to understand this service.yaml, right? What are all these things over here? So name, service name, this is the name for the service. This part, selector key value, is actually how it even chooses which pods need to be sent this traffic to, right? So pods have labels which are key value pairs, and in the service, if you say selector key value, all the pods which match this key value will be chosen by the service to send traffic to. So it doesn't magically or automatically know which pods to send the traffic to. This label key value, this selector key value is the ones which will say that all of these pods which have this key value pairs need to be chosen and send traffic to. And finally, 2 ports. This is the port on the service itself. So an external connection will be to this service port and services port, and target port is the port on the pod which this service will then target.
So I deployed the client.
You did the client deployment with one of the pod IPs, right? Yeah. Okay. So now you can deploy the service also. You can create the service YAML.
Yeah, but before that I was trying to see the
logs and.
I can't see anything. This was the deployment.
So you need to do to Nginx/user HTML so that if you do curl, because the client is doing curl, right?
Yeah.
So it will only print what result it gets from the curl.
Okay.
So if you write to the index.html, when the client does the curl, it will not reach the default Nginx page. It will reach your page, the one which says this is my hostname.
Okay, that index.html.
So it will reach this new index.html that this pod will create and keep. So then only when you see the client logs, you will actually see this message being printed in the client logs.
Okay, for that particular pod, I'll have to change that index.html.
No. So this is the pod command, and here you have to say echo hostname, but write it to /user share nginx html index.html.
Okay, that command that.
That I had put over there. So if you put all this over here, the pod on starting will write this and put it in index.html. And then when the client is connecting, it will see these logs. It will see this message in the logs.
Okay. Got it.
So just change this command to that one. Very hands off it became.
Yeah, yeah. क्या बोलते हैं, तारीफ कर रहे थे. It's not like we are kind of, I don't know what to do. You're looking very smart today. Something
Put it back. I always just leave it right.
no, that's hard.
You know, we don't wear. I feel very awkward with this.
Very smart. The attire is very smart. So, all of a sudden looking good.
What is happening? It's like going to school, right? Like we're following. Are we able to run the deployment?
Server till done.
Okay. So first the basic client pod you want to try, right?
Yes.
Okay. So if you do after server deployment, you can do get pods override to see the IP of the pod. You're able to get an IP of the. There will be 2 pods. You can get the IP of. Do get pods -o wide so that you can get more information. Now get pods -o space wide.
Wide.
WIDE. So this will bring more information, which includes the IP of the pod. So the server deployment, we want the server deployment, just pick one of the IPs. Not that one, that's Nginx. The last 2 are server deployment. Now go to your client.yaml. And you can insert IP here is there, right? You can write the IP, this IP over there. Now you can get copied. Okay. Now I'm going to save it and now you deploy this client pod.yaml. Underscore pod.yaml. Okay, now if you see the logs of the client, and in the next slide you'll see this logs. Cloud kube control logs client pod. Next one. You will see that one of the pods is being reached. So I've already been able to create this service.yaml. We've been able to get it at least from this GitHub repo and deploy the service. Can you all get it?
हमको बोलते हैं
That key value, what do they have to write?
So if you see the pod YAML, right, the server deployment, just see the server deployment at YAML, just open that. So you can see a label here, right? App server pod. So it's over here, label app server pod. So you can just copy that. You have to use the same thing in your service. So anything that has this label app server pod will also be reached by the service. Just put this app : server pod. No, this line 13.
Just open that one again.
This means select a key value. You can remove line 7 and put this instead. And just take care of the indentation. Yeah. Okay. And port, you can choose any port on your side, but the target port has to be 80. Nice. I think a few people are writing their service YAML from scratch. You can just pick any port here. Okay, where are you?
This client port, but
Did you deploy the service or before the service? Before the service. Okay, yeah, show your part. Not found. No, you shouldn't do .yaml. You'll just do client pod. If you use the name of the pod, no, it says that also not found. It is running. Control. Not underscore. You have to use the name of the pod, which is client-pod. I think the server deployment, maybe there's an error in your command. So you'll just show that.
This, like, it's showing the port number to be 9000.
9000, right?
For the service. But when I write it in this client environment, it
9000. You have to use service IP
but it
9000.
doesn't then apply. Like it shows an error. Where do this?
Oh, when you change the service client YAML,
Yeah.
then you have to delete the client YAML and then apply it again.
which IP do you have to use?
Use any of the pod IP address, you will see it. No, what did you say? No, just copy one of the IP address. Delete it, wait for delete and then apply again.
It's writing deleted, so can I?
No, just wait for it. You can go control. No, just wait. Only after it releases, it will. Move. Nobody listens.
Before notebook, stop. Don't cover notebook.
Yeah, so I hope you're able to deploy the service. It should have a port and a cluster IP. This cluster IP is the same cluster IP I was referring to before. So this is the IP with which any pod in this cluster can now reach the service, and this is the port that it is accessible on. And if you take a look at the service, right, so in Kubernetes, you can use the kubectl describe command to see the detailed YAML of anything that you deploy, which includes deployments, pods, services, anything. So if you're just interested and you're done with everything, you can describe anything that you have deployed before, and you can get a lot of information, including stuff that Kubernetes has internal information that Kubernetes maintains about your resources. So you can see in the service, you can see this thing called endpoints. So endpoints is how service actually keeps track of which pods are actually running, and this refers to your pods IPs. Whatever you see in your own describe of service, this will refer to the pod IPs, which is the backend pods in your system. And you might have to delete your client YAML if you make any changes to the cluster IP now. Finish? There's one girl over there was writing the service YAML from scratch. I was like, somebody's even doing this.
So, next session, you take the remaining part of the fourth session and cover thoda sa theory, na? of
No,
the
it's okay.
ingress.
No, it's okay. Oh, ingress.
I mean, I'm not going to cover it.
I think if you keep time for the hands-on also, it became very, very hands-on. It's okay.
Don't do hands-on. Just complete your theory at least. At least they should know end of the day कि ingress करके power से access होता है. Just cover that one at least. Then I'll take over because we don't have a lot of hands-on in that. Even one hands-on in next session.
This thing.
That rate limit. That's it. Once that is done, then that's actually hopefully it works.
Deployed. Deployed. And then do notepod also.
No, notepad I tried. Its curl is not working.
Huh? Curl you should. No, because we need node access. Because
So just stop. Don't do.
When ping is not working, so I tried to curl.
Notepod के लिए नहीं चलेगा.
Because it's not, that machine is not accessible. We are 2 machines away actually. I thought we'll get access to that machine. So if you deploy a client against the service, what you will notice in the logs is that each time we do a curl, we will get a different backend. It will be probabilistic, so you will not necessarily swap between both of them, but you'll reach a different backend each time. So I have just given the description of a node port, how it looks, but it might this will not work for you from your current machine because the node IP is not reachable from your machine. So that is also one of the requirements for node port to work.
But when I create it, I'm not getting any.
Yeah, you will not be able to curl from outside. You can do the client pod though, again. I don't know if the client will be able to reach it.
So basically, it says right, like for me to get, I have to get the IP of that node. Right?
Right, you have to get the IP of the node, and then whichever get node /show wide.
Node is not showing.
No, this is the node. 3.57 is the node IP.
This one? The name is not here. I created with some other name.
No, node is the Kubernetes node.
This is the
Kubernetes clusters node. So this is what was created when we created the cluster. So this is not, you can only read, you can't change these things, right? This is the admin thing. He didn't realize, anyway, not. Actually, it's done. I mean, if everybody's done with the service.
For tea, you can go to tea place, but also Sudhir is tea.
Okay. Yeah, if everybody's done. Careful. Alright, can we get a show of hands of how many of you are able to deploy the client against this service? See the different backends being reached every single time, and that is a Kubernetes service in action. If I was not able to cover the how does the service work, you can look at these slides if you want offline to see how does a kubeproxy actually do this routing to the correct pod. We can break for tea now if you're all done with your.
Post also
No. She said ingress we can do. Okay. They said you can do ingress if I want.
Okay.
But it is also.
It's also new topic. Whether you can finish the kubeproxy.
That is, it will take
Theory,
fully theory.
You're introducing a new concept for no good reason.
Ingress, because it's not a part of her hands-on anyway. So we can cut it.
It will completely remove. Very theory, very theory. But don't skip the theory of service. Don't. It's the best practice.
But if
on the side, service mesh will also cut the practice. We'll cut it out to make it more.
Completely.
Or keep it very minimal. 10 minutes go through who was doing the faster. There's no point in using the concept again.
But I don't know if they're listening. The what also? கொஞ்சம் மூடி ஆயிடுச்சு.
இல்ல அதெல்லாம் ஓகே.
நீடா.
Yeah.
Guys, apparently there's something wrong in tea, so let's go have it before it gets cold and come back.
Okay, yeah, let's just sort of a continuation of the previous session, right? Where I wanted to also show you how does the Kubernetes service work. It has these pods that are backend. How does it know which pods to send it to, and how does it even do that? How does it transparently send a request coming to it to somebody else? So understanding how services work. So let's just see this diagram and talk over this diagram quickly, right? So there's this component called kubeproxy, which does all of this magic. So kubeproxy actually runs on every single node. Yesterday we learned what is a Kubernetes resource that is deployed on every node. Anybody remembers the name? Unlikely.
Guys, please answer. You're asking a question.
Anybody remembers the name of a resource in Kubernetes which we deploy on every single node? Priyanka was saying that yesterday, same session yesterday. Anybody remembers its name? So it's a daemon set. Basically, daemon set is something that runs on deploys a pod on every single node. A kubeproxy runs on every single node. It is a Kubernetes internal component. So suppose a service is created. You deployed a service, right? You created your service with your own name. So suppose you created this service. You call it a cluster IP service, and when you create the service, it has a virtual IP that's assigned to it. And suppose these pods that you want the service to send it to, right? Suppose these pods are already running. You have a couple of pods. Now you create a service. This is exactly how you did the deployment. You had a server deployment which had multiple pods. You created a service with the label same as the pod label so that these pods are being referred. So you created a service. Now what happens is that Kubernetes creates these endpoints. It has its own special term called endpoint to refer to a resource, which is basically an abstraction over this pod, basically an IP, right? What IP should I send it to? It's an endpoint. Yeah, basically Kubernetes uses this label matcher to say that these are the pods that that the service is interested in, and let me create an endpoint for each of these pods. Now these endpoints have to do a little bit of work, as in Kubernetes does it, the Kube API server does it. Basically these endpoints have to verify that this pod is up. So how does this help us? Is that if the pod is down, do you want to send traffic to it? No, right? So it should not be counted as one of the backend pods for load balancing if it is not even active. So if this readiness probe is something in Kubernetes which verifies if a pod is up or down. Basically it just keeps sending some pings to it, and if the pod doesn't respond back, it knows that the pod is down. It assumes that the pod is down. So using this readiness probe, it verifies that this endpoint, whether it's active or not. And if the endpoint is not active, don't send requests to it. So these endpoints will, so there will be probes that are running to ensure that these endpoints are up, and they will tell the Kube API server, which is again one of the brains of Kubernetes, that okay, you have two endpoints that are matching the service and both of them are up. And the API server then informs kubeproxy, the network brain of Kubernetes, that this service has these two endpoints that are up. Kubeproxy will go and modify IP tables. So you guys saw IP tables on the first day. There was a hands-on session where you were able to modify the rules. You had this filter and add table and all that. So kubeproxy goes and modifies the IP tables on that node, saying that if you get a packet to this service IP, you should actually send it to the pod IP, pods IPs. Now, the reason why kubeproxy is running on every node is because these rules also have to be on every node. Because if one node doesn't have this information, if a packet comes somewhere in this node, or if the client pod is on this node, then that node doesn't know what to do. So these rules have to be on the node host machine itself, and they have to, therefore it has to be on every single node that makes up this Kubernetes cluster. So these rules say that if there is whatever is a request made to this virtual IP, it has to be sent to one of these two IPs. So how does it send to one of these two IPs? Is first thing you have to do is the NAT that they were talking about that day. That is something that comes to VIP is transparently changed to one of these pod IPs. And the second thing is that IP tables has this option that if you give multiple rules and you can say that statistically use 50% probability to split traffic between them. So that is how it also handles load balancing automatically using IP tables. So the thing is that kube proxy, though it is named a proxy, is actually not a proxy, because a proxy will take requests and it is in charge of giving it to someone else. Here kube proxy is not taking all the service incoming requests and giving it to the pod. It is installing rules in the node which say that if this node gets a request to this service IP, it will send it to the pod. So kube proxy is not a proxy, it is basically just an installer, one-time installer of rules and then leave. And one time is the first time, but now if a pod goes down, or if you added more pods to this replica, so if one more pod comes up, then one more endpoint will come up, and then this kube proxy has to go and update that there is an IP3 also that has to receive this thing. So it is one-time installer plus modifier every time something changes. If a pod goes down, then it will cancel that rule from thing. It will keep modifying it, but this is basically how on every node we know that if a request comes to a virtual IP, the service IP, there is nothing that is actually that cluster, that service IP means nothing. It just ensures that there is a network address translation rule that a packet incoming with that destination address is now changed to one of these addresses as its destination address. What did I add? So when a client sends a request to this service IP using this IP table rules, they are using the IP table rules, the cluster IP or the destination IP in the packet is transparently changed to one of the backend pod's IPs, and now the pod is routed to this pod IP address, and that is handled by the CNI's pod routing, because it knows how to do pod, how to send it to a pod. It just doesn't know what a service IP means and what do I do with the packet which is sent to a service IP that it can't handle. So these are the IP table rules in Kubernetes. Yeah, I think this also shows this in action. You have a client on one node, on one pod, a pod on one node, and you have this server as a pod on another node. Suppose the client is sending a packet with destination as the cluster IP on of a service on this side. Then the IP tables on the client's node itself will change the destination to this server pod's IP, which will help it go there. And when the response comes back, there is an additional complication that the response can't be sent with the server IP, because this guy sent a packet with the destination IP as a cluster IP and is receiving a response back with some other IP as a response, so it doesn't know that this corresponds to this. So the IP tables on this side also ensures that you change this, sorry, where is it? The destination was wrong. You change the destination back to, right, I think I should change the source. You change the source back to the cluster IP that's in the response. Yeah, that's it. We'll go to the next module that we have on service meshes.
So, what we've learned till now today was around Docker networking and understanding how networking works in Kubernetes using CNI. And then Kavya went over how you connect to applications that are running on the cloud or your cluster from externally using, like internally how you connect, as we saw yesterday, using services, right? And next we are going to talk about service meshes and wrap up with a very brief of what we are doing and understanding where the world is in the cloud environment industry, right? So let's get started, right? So this is what we've seen till now, that services are used to be running in front of any application that you're running. It's abstraction, as Chandra had asked you, and it can be helped to connect to any application that's running on the cloud, right? So okay, so this is something that we had skipped from last time, but what we have to do is, in case you want to connect to your application from outside the world, right, not in parts of the cluster, you have to create something kind of a ingress gateway for that cluster, which opens up ports so that packets from outside can come into your, or requests from outside can come and hit your applications that are running in the cloud, right? So internally what happens is, suppose you have the request coming in, and all these ingress you can give an endpoint. The endpoint can be, if you want, a bar, my.app.bar, or my just this URLs, and based on these it gets mapped to the services, similar to, like, these are kind of the services that we got used or created in the last session with Kavya, and that's when these once they hit a service, the processing is similar to what we had seen in the last session, right? So this is how requests that are coming from clients outside the cluster, outside the cloud environment, hit the application at the end, right? So services have been there, being used in different terminologies across various applications that we've been doing till now, right? And they've been, so you've seen that you need, for any application, you need the service running. So imagine any application that you have or you've been using in your day-to-day activity, be it Swiggy, be it Uber, be it Amazon. Imagine that you just had one application now and you had to trouble creating and following how the services work, right? So imagine whenever real application gets deployed in a cloud environment, it would have n number of microservices running, and they need to be communicating with each other to process, right? So your payment should go back and handle some requests and come back. Your shopping cart will have to go pay, when you do a buy, it has to go back, pick up the address and come back. So there are, all these are handled by individual microservices, right? And they should all be talking to each other. So this is kind of what kind of happens when you actually deploy a real big application, where there'll be a lot of services talking to each other, right? So what we generally have is, the application developer doesn't have to need to worry about, if you had to build your complete application, be it a payment application. There are a lot of stats that go into that. Okay, I have to pick up something, some credentials from a database, do some processing on it, then send it out to some other application, right? So along with that, so one application comprises of the processing unit, like the core processing that the microservice has to do, and along with that there needs to be some networking that happens, right? Because it has to communicate with services that are there, other that it has to talk to, right? So this networking thing is something that's not the core application logic, right? And as we said, or as we saw in our journey yesterday, that you don't have your whatever runs, only a single processing unit kind of thing should be running in your containers, right? Or only the processing should be running in your containers. So what kind of architecture is followed by most of the applications right now is, you have your microservice where your core app processing logic runs, and there is a sidecar running which handles all the networking for you, or all the requests that you want to get through, go from your processing unit through this sidecar container which does networking, and out to any other microservice you want to, which also has this networking running and the sidecar. So you can see this blue here, the light blue here are our sidecars which handle your networking part for these microservices which want to talk to each other. So as you can see, there are multiple applications or multiple microservices that consist of to build a huge application that are deployed on the cloud today. So what these communicating with each other is what comprises of a service mesh, right? With all these things talking to each other. Right? So as this is something I spoke about right now, that why did you have to separate it? Because you have to decouple your application logic from your networking logic, right? So there are not just the service mesh, the sidecars that handle the networking.
just don't do the traffic, sending out the traffic part. There are multiple functionalities that are required along with just handling the request and response and giving to the microservice, right? We'll go over some of these right now. So one thing that you can do is it can help you route, right? It can see if there are multiple requests coming. It can help you identify what request is coming, what HTTP header it has, that kind of, and it can decide if you want to route it to some other microservice, and all that kind of decisions can also be done as part of this sidecar, right? And other thing that you can do as an application developer using this sidecar is test your microservice. Right, so what you can do is you can use it for adding some delay or dropping sample packet or trying to do some attack on decrypting it or something like that. Right, so all that kind of testing can also be done separately from the microservice developer. So a microservice developer can design or develop his microservice, and another developer can test this using a sidecar that's get attached to your microservice or run the application. Right, so another thing that can help in application deployment on the cloud that these sidecars can support is shifting. That is, that's a continuous cycle that happens when you go with the application development, right? So you have to, there would be some service that's running, there's some microservice that's running, and all the traffic goes to that application right now. So once you have a newer version of your application up and you want to slowly move to it, right? You don't know how much load it can handle in the real cloud. You want to slowly move into it, and that's when you want to slowly bring in that service. So you want to ensure that the requests that go to it don't come in at a moment, and slowly, suppose 50% of 100% of requests going to service A, and now you have the new service B. You want to make sure that when 90% go to A and 10% only go to B, all this can be handled without any changes in the microservice, because all this can be handled as part of the sidecar that's running along with the microservice, right? So this is something that we'll see as part of a small implementation as a hands-on in this session, where we'll we'll actually try to limit the number of requests that go to an application, so that this is a very good use case for it. So you must have heard of denial of service attacks or brute force attacks on any application that's running on the cloud, right? So why does it happen when you have send a lot of requests to any application, right? And with these number of if there is no limit set, you can actually crash the application that's running in the microservice, right? So rate limiting is a very important feature that's required, and again, this need not be what the microservice needs to done. This needs to be something that the microservice developer doesn't need to handle, but it can run as a sidecar, and it can actually help bring limit the number of requests that are handled by a particular particular app microservice, so that it doesn't crash in future, right? We'll skip some. Okay, so another important feature that sidecars can help support is observability, right? And we had mentioned yesterday as well that once you have such huge applications running on the cloud with like thousands of microservices running, monitoring them is a very critical thing that needs to be done. You need to continuously monitor and see which of the microservices is failing, why is it failing, and what are the reasons of its failing. So for doing that, you need to collect observability data like metrics, logs, to interpret number of requests handled by a particular microservice, or if it is dropping some requests, the logs will give you out that, okay, this is a reason. That you must have seen in the last session, right, when you printed out logs, some of you guys got a timeout request or something like that, right? So these some kind of logs help you interpret that something's wrong with the microservice that's running. But again, this need not be something that the microservice runs as part of its own core processing logic. It can run as part of the sidecar that's running along with your microservice. Yeah? Yeah. So this is just a small interpretation of the Twitter website on like Twitter post. and you can see that there are multiple things that are involved, and each of this gets implemented as a single microservice, right? This is just one post. Imagine the whole thing, and it involves, and you can see the number of microservices that are needed go on increasing, right? This is just for one tweet, right? And with and you can see that all this needs to be managed for each and every microservice that gets deployed here. That is, for each of this, you need all the features like for fault injection, version upgrade, rate limited, all this needs to be done, observability, all this needs to be done for each of these microservices. And with the number of the scale at which these applications are running, this gets more and more difficult, right? So this is just for you to imagine. This is kind of a microservice chain example of the interconnection shared by Uber. So the blue dots here are microservices, and the gray lines here are the microservices talking to each other. So you can imagine the number of microservices that are created, and the number of, imagine the amount of connection that are there, microservice connection, and how many microservices are talking to each other, right? And
any guesses on how many microservices Uber runs? Yeah, in production.
50,000.
How much? 15,000. Okay, we have one number. Any other numbers? Guesses? No? Okay.
yes.
The answer is 4,500. Not very. But yeah, so just imagine, right? You're running 4,500 services. Just imagine the scale of how you will manage this and how will you. We have been running one service today, and you know how problematic that is.
Yeah, so doing all this for so many microservices day in and day out is a very tough job for any application developer, any site reliability engineer who is managing the cloud environment, right? So
yeah, there is a follow-up question here. Again, any guesses? So it's not just that we have 4,500 services, right? So you're changing something, you have to redeploy it, you are bringing down deployments and bringing them up, right? So can you imagine the total number of like redeployments that happens every week in Uber? Going with the same Uber example. Right? Some numbers, please. You just guess. Twice, thrice, okay. Neither guesses? Huh? 5 to 10 times, okay. So the answer is 1 lakh. 1 lakh redeployments every week, right? So the thing is, this microservice pattern just encourages people to deploy, push code every two hours, and then just automatically redeploy, right? So your entire system is like continuously in a churn where you're upgrading things, testing things, moving up and down. And just imagine if you had to change things like, I mean, it probably gives you an idea, right? If you see these features you're talking about, observability, rate limiting, why it's so important now, right? A single bug in one of those can just cause serious DOS on another if you didn't have something executed, right? You can just imagine this.
yes. So this is just our interpretation of how the sidecar works for your microservice, right?
People know this reference, right? Because I had a doubt we are getting old and this next generation doesn't know this. You don't know? Some people don't know? Surely, this is surely. Okay.
Okay, we are
go back and see this film. Or ask your parents about this film.
Right, so as we said that you need a microservice and you need someone to handle your network processing or whatever tool sets we discussed till now, and as Chandra said, at such a scale doing it with so many redeployments, it gets tougher and tougher, right? So what we have generally, how the applications are deployed, this sidecar runs what is called as a service proxy, right? So what happens is whenever a request comes, as we said, it gets processed at the service, or like it and the request processing, the header or interpretation or whatever rate limiting observability happens at the service proxy, and then the request goes to the service that's running or the processing unit that's running. Then and the same process happens in the egress also. That is, it goes to the service proxy and then out to the other, like it's a microservice chain, right? So X, Y, Z are the just a small interpretation of 3 microservices that are running. Ingress from one processing, egress to the other microservice chain, processing there, then egress to another microservice chain, and so on and so forth. And after that all processing is done, you get the reply back to your client or your browser, if that's the case, right? Or your app that's running, Amazon or Uber, right? So what runs in this service proxy? So that's what we are going to do today. So what we are going to use a small example example service proxy today. So what is an example that's widely used in cloud environments today is what is called as Istio. So what Istio does is Istio helps deploy these sidecars to your application, right? So these are kind of L7 proxies that get deployed along with your microservice. So the proxy here is what becomes the envoy proxy here in case of Istio, which runs along with your microservice and handles all the operations like fault injection, observability, rate limiting. All these things are done at the envoy proxy that runs along with your service on the cloud, right? That's how this Istio works, right? And it obviously has a control plane running on the cloud to manage all these sidecars, right? Because it provides you a good environment to handle all these sidecars and how they are because these also need to be monitored in some way and need to be seen if there's some downtime happening or some issues happening with these proxies as well, or you need to configure them also, right? Because you might require some configuration required for service A. That is, I require rate limiting for service A, but I don't require rate limiting for service B. I maybe need to do some testing for service B. So there will be different requirements required for different microservices, and all these need to be managed some way. So Istio also provides you a control plane to do that. Yeah? Yes, so we are starting the hands-on. It's a short hands-on as of now. This is one hands-on that will be part of this session today. So what we are going to do is see how the rate limiting happens for these microservices, right? So in the same cluster that we've been using since yesterday, which we are logging in, what I'll suggest is in the Slack, we've given you a link to a YML, that is bookkeeping YML. Along with that, there is another YML called local rate limit.yml in the Slack. Just download both of them in the same exercise folder that you had used in the last session, right? Let it be in the same folder that you had used in the last session. So once you're done with that, we'll proceed with playing with this microservice chain. So basically with this YML that you're using, that is the bookkeeping YML that you'll download, it actually deploy not just one, but 3 or 5 microservices that will be running in your namespace, and that's how we'll see how rate limiting works for this microservice chain in action. One thing we might face is something that we faced yesterday when you started deploying more than 3 or 5 microservices in your own namespace, right? So if that is the case, what we recommend is, can you just tag along with your neighbor here and just have one of you guys deploy it in one of the namespace and see it together, because without that we'll face the pod limit that we had faced yesterday. Is it fine? हो पाएगा क्या? हो पाएगा?
प्रैक्टिकली चेक तो नहीं की थी
हाँ
कि हुआ है, बट
दिख रहा है. ओके, 5 minutes हो गए. ओके. Okay, so we have a good news. Thanks, Shambhavi. She has increased the pod limits, which is by default 110 in the cluster that we had, to 500. So I think you all can try. And if you're facing an issue, then we'll see it. So maybe all of you can give it a try. Yeah, thanks. So what you have to do is download the YMLs that are shared on the Slack channel. Right? Once you download it in the exercise folder, in the exercise folder, then we proceed from there.
Nobody's saying anything. Hopefully they're download. Once they download, once the apply thing starts, then the issues will start. So, has everyone downloaded the manuals? Yeah, in the exercise folder, do you have these manuals now? Show of hands, please. Okay, great. So what you have to do is, in the same namespace, we have to tell Kubernetes that I want to have Istio enabled for my microservices that are running in my namespace, right? So this command will enable it to install the Istio sidecar in your microservice, right? So for a good, I'm hoping you guys are there on your namespace itself. If not, the set context command, kubectl set context command that we had shared in the start of the last session, use that to go to the namespace that you've been working on last session, right? Just go to that namespace and run this first command of enabling Istio for your namespace. Yeah. You need to run it wherever that control alias command.
What was the name of it?
Your namespace. Okay. And multi-cloud will do? Okay. Usually there is a user not able to connect to Kubernetes server.
Okay, so do you have issue injection enabled on your namespace? Show of hands, please. Okay, great. So what you have to do is you downloaded the YML from online, the book info YML into your folder, right? Right. So now you want to enable the microservice chain in the individual namespaces, right? So in case, so if you're in your individual namespace, just apply this book info YML that you got, that you downloaded on from online. And once you deploy, just do kubectl get pods, and you'll see a bunch of microservices running. And before we start, in case you had some old microservices, like old pods running, and I'll request you guys to just delete these pods from your namespace before starting out. Otherwise, we might hit if there are a lot of pods already there in place, right? So just delete your any old old pod that's running, and if it was deployed using deployment, then go ahead and delete the deployment. So if you do kubectl get deployment, so if you do kubectl get deployment, it will list all the deployments that are running in your namespace. Then you can do kubectl delete deployment, the deployment name, that will delete the deployment, right? And then start applying this book info YML so that we don't hit the pod limit. Any issues? No, no.
So the prompt is where?
We just apply in case they now see the pending state.
Some of them have the pods.
Ready? Increased it. Yeah, I did not know.
I realized communication gap. Right? You were saying I went out and heard you saying
So, how many of you guys have some new pods up on your namespace? What are those? Correct. Awesome. Right? So this is kind of, I know ideally we could, when you are an application developer, you write your own YAML to enable what ports to expose and what service to create for that application. But this is just an example for us to use, and this is something that you can go and see as well to see how microservices are created, microservice chains are created, how services are created for these microservices as well. If you open the book info environment, you'll see multiple objects being created for your microservice chain. Yeah, so if you have your pods up, what we'll do is, as we said earlier, we'll do some rate limiting. So what happens is, this is the microservice chain that you got deployed with the project page, reviews, and ratings. What we have is in each of these namespace, because you enabled Istio, you have the envoy running on each of your namespaces, and we'll add rate limit to this envoy, right? So we'll tell Istio that I want to enable rate limit for this namespace, right? So how is this working? It's working because in the background, we in this cluster have enabled Istio to be running. So there is an Istio control plane already up in this cluster because it required root permissions and not everyone will do it. It's a cluster config that happens. We've done it initially for you guys. So the Istio is already up there, and that's why your Istio enablement worked, right? These gateways, what they will be called, I think, ingress gateways or book info gateways that are running on all of your pods, right? So we'll add a rate limit now for your microservices. So what we do is just the request coming to product page, we'll limit it, right? So how do we limit it? How this rate limiting works is it internally uses a token bucket kind of implementation to do this rate limiting, right? So anyone has an idea how token bucket works? Anyone here? Right, so how to, yeah. You can come here and talk. I want you to come.
So it's basically, as you can see, you can consider this token as a bucket in which, let's say you are putting 3 or 4 coins every minute or something, and for each coin you can serve a service. So that the number of coins you're putting per second defines the rate at which you can perform the service. So it's like that kind of thing.
Perfect. Yes, so for each request there is a token, and to serve each request each request gets a token, and only number of tokens that are there in the bucket is the number of requests that can be serviced at any given moment of time, right? So, and this number of tokens get refreshed after a certain number of interval that you can configure. So in our case, we'll see the YML later, but in our case, we said that the max tokens, we have set it to 5. That is, at any given moment, only 5 requests can be served. And every 60 seconds, this is a fill interval. So every 60 seconds, new 5 tokens will be added to your token bucket. So every 60 seconds, more 5 requests can be served at every 5 seconds, right? So that's how the token bucket architecture works. So we'll use this rate limiting architecture to limit the number of requests that are coming to the product page. This is kind of our front end for your microservice chain. So we'll limit the number of requests going in with a token bucket running here, right? So what you have to do is we had shared local rate limit.yml in Slack. You guys had already downloaded it into your exercise folder, yes? Right, so what you have to do is go there, open that YML and look over it. First thing you have to do is there is this namespace in quotes. So you have to remove these quotes and put your namespace name instead of namespace here, right? Replace whatever is there, remove the less than greater than sign and replace the namespace with your namespace name. And once you've done that, apply that file in your namespace.
And this local rate limit.yml file is not.
Did you download it?
Yeah, it's there. And I have also.
Yeah, can you open the file for me? Oh no, apps. No, not at apps. Here, namespace should be.
So I have changed the namespace.
Is this your namespace that you had created?
Yes.
Okay. And what is it? Can you show me what's happening?
So this is the same namespace that I was using over here also. I have changed it over there. But it's showing converting ML to JSON, ML line to mapping values are not allowed. आपके में भी same आ रहा है?
Same आ रहा है क्या? कुछ फाइल में इशू है फिर? Can you open the file for me again?
Yeah.
Just remove the first line. I'm so sorry. Remove the first line. Can you just try it again for me to confirm? Not sure how that came out.
And this also should.
Yeah. Can you go to line 64 for me?
Now the line 55. Now the error is consistent.
Can you next one? Just remove the EOF. Oh shit, वो मैंने फाइल देखना है. Guys, there's a small change that's required in the file. The first line and the last line of the file is something that's need not be in that line. I'm sorry for the issue. Just remove the kubectl apply line in the YML and the EOF in the line end of the YML. And once that works, save that and apply it. Right?
Before applying the rate limit, we were able to see the difference.
Yeah, we could have. We are actually short of time. Actually, 5 बज चुके हैं. उसके बाद मल्टी क्लाउड खत्म करने इसलिए. क्या? हाँ, जो नेक्स्ट कमांड है ना, वो उससे कर्ल है. वो कर्ल कमांड है. वो वही चल रहा तो 5 बार चला दोगे. मैं वही बोलने वाली हूँ अभी. So how many of you have this rate limit applied? Awesome. So run this next command. This command, what it basically does is it just does the curl to this product page, which is kind of our front end for your microservice chain, right? So just copy paste this command and try it. What you will see is, I want to see what you will see actually. Yeah, run it 5 times. You got it 429? What do you mean by 429 in the HTTP code? Yes, it's rate limited. Yes, exactly. That it means it's getting rate limited. The requests are getting rate limited. So wait for a minute. You remember, right? We had told that fill in the request after a minute. So wait for a minute and again try. It works again? Yes. I want others to do that or feel that as well. Run 5 requests continuously. That is, you run this line 5 times. Then after a minute, again try, you will get a 429 after the 5th request. And after a minute again retry, you will again see it succeed with the 200 output. So, can I have a show of hands? How many of you could get the 429 and again a 200 back after a minute? Awesome. So, this is possible because of the rate limit that you applied through the file that you just applied, the local rate limit. And it has this line, or you would see this exact same thing happening where we've configured that it can accept only 5 tokens and handle only 5 tokens, like refill only 5 tokens, and the fill interval is 6. Because of this is what you were able to get this rate limiting in for your product finish, right? Awesome. So next we'll move to multi-cloud. But just give a minute for others to just get to a page where they can stop doing their hands-on, and after this point we just talk about what's there in this cloud environment right now, and it's just a story for you to hear, enjoy, right? So just give us a moment and let others reach the stage where they can sit back and relax and listen to what we're going to tell now. Thanks.